So big little logic kind of comes down to thinking about numbers and how they're progressing opposed to calculating an exact value. So here's another example of big little logic. So if we were going to find the limit as x approaches 4 from the right-hand side of x plus 4 over x minus 4. Step 1, just like always, before you even jump into big little logic, you're going to throw in the number 4 and say, all right, this would be 4 plus 4 over 4 minus 4. And you recognize that this is 8 over 0. And because it's dividing by 0, it's not 0 over 0. Therefore, it is not a removable discontinuity. It is not a whole. This is a asymptote, right? And because this is an asymptote, we are going to use big little. All right, so now, what are we going to say? Well, instead of substituting in the number 4, what we're going to do instead, there we go, is we're going to say, okay, this would be when I have I'm just going to fix that. Okay, when I have a number that is 4 from the right-hand side, a number that, or the other way of thinking about it is it's a number slightly bigger than 4. So instead of 4, it's 4.00000001, right? Minus 4. Now, when we say big, what we mean is infinity. It's another way of describing infinity. When we say little, we mean 0. It's another way of describing something that is 0. Now, just like infinity, you can never reach infinity, right? You can just get close to it. So when we say big, we're not saying at infinity. We're saying as we approach infinity. Same thing with little. Little is not at 0. It's as we approach 0. It's as numbers are basically 0. They might as well be 0, but they're so close, but they're not actually 0. So what we'd end up with here is when I put the same 4 up here. Now, for the numerator, if I put 4.000000 whatever 1 plus 4, I mean, basically that numerator, we're saying that's 8, right? I mean, it's 8.0000, but basically it's 8. Down here in the denominator, it's 4.00000001 minus 4, so that'd be 0.00000, however many zeros I wrote, 1. Now this, instead of writing all of that out and having to try to look for patterns or whatever, we're just going to say that's a really, really little number. That is approaching 0. That's why we're going to say it's little. Because when I do 4 from the right-hand side, when I do the limit as 4 approaches from the right-hand side, we're not really at 4.00000001. We're way closer than that. We're at 4.0000000000, right? It would go on forever because we're just getting as close as we could ever get. So basically, that number is little. So we're going to have 8 divided by something little. This is another problem I'm going to do. Hold on to that one. Ignore that over there. Okay, so therefore, what is 8 divided by something little? Well, the idea of if I had anything, 7 divided by 0.1, right? That's 70. 7 divided by 0.01, well, that's 700. And then 7 divided by 0.001, that's 7,000. And if we continue this forever, what you'd see, you can already probably see the pattern of, is as these numbers get closer and closer and closer to 0, when we divide by something little, our answer is getting bigger and bigger and bigger, so therefore it is going to get big. And as I described up above earlier, big is the concept of infinity. So a number divided by something little makes infinity. Now, if it would happen to be a negative little or a negative 7, well, a negative divided by a positive makes a negative. So therefore it is a negative infinity. Okay. So here we have to ask ourselves, 4.0 minus 4, that is a positive little number because 4.00000001 is bigger than 4, right? So therefore it stays positive. So it's a little number. So therefore 8 divided by something little is infinity. It is something big. All right. So similarly, let me just kind of show you really fast the negative little concept. The limit as x approaches 4 from the left-hand side. Same problem, x plus 4 over x minus 4. So now what we're saying here, same problem, but when I plug in instead of being 4.000000000000000 whatever one, since it's on the left-hand side, I need a number that's slightly less than 4. So that might be 3.9999, right? So 3.9999999 going on forever plus 4, that is basically 8 in the numerator, and 3.9999999 and so on and so forth, minus 4 in the denominator. That you can see here, 3.999 minus 4. Well, 4 is bigger than this, right? So therefore, 3.999 minus 4, that makes a negative value, and it is a negative 0.000000001, or aka little. See, so that's why the big little logic is kind of awesome. It helps us just kind of speed through and use our brains instead of having to sit here and write out numbers and try to look for patterns and make tables of values. You can use your brain. You can get through the problem in 5 seconds. And later on, we're going to get to some problems where you just can't make a table of values. It ain't going to work. But you can use this, and it works great. So therefore, negative 8 divided by a negative little, just like before, dividing a number divided by something little is something big, and a positive divided by a negative makes a negative. So therefore, the answer is negative infinity. Okay, so there's a little bit of big little logic in that style. Now, a separate problem I want to do with you is this one, where you can see I have the limit as x approaches negative infinity of 1 over 7 plus 1 over x. All right, so you're not allowed to substitute in infinities because it's not a number, but you could just say this is a negative, really, really big number. Now, I mean, if we say negative big, right, think about this is negative 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? Just like before, it's just something gigantic, and you could just keep writing these zeros forever. So instead of that, instead of writing all that out, though, we just write it's a negative big number. Because now, big little logic just tells us, all right, let's see, 1 over 7 plus, what is 1 divided by a negative big number? What is, well, a positive divided by a negative makes a negative, right? So we therefore know it's going to be negative. The answer to this would be negative. Now, what is 1 divided by something big? What is a number, and it doesn't really matter if it's 1, but what is a number divided by just something gigantic? Like, so think of it this way. 1 piece of bread divided by everybody on Earth. I don't know if that's how many people there are, but how much would you be getting? You'd be getting something approaching 0. You'd be getting something very, very little. Would it be 0? No. It'd probably be like an atom of bread, maybe a molecule, I don't know. But it'd be something so little, it might as well be 0. That's how we use the big little logic the other way. So when we look at this, we're going to say 1 divided by something really, really, really big is basically 0, and a positive divided by a negative is a negative, so therefore it's a negative 0. Now, the good news is it doesn't really matter for this problem if it's negative or positive, because 7 plus 0 makes 7. So therefore, the answer is 1/7. Okay, there's a couple more examples. See, I hope that helps. Let me know. If you need a little more help, let me know specifically where you're getting stuck.